Hi, welcome to this short presentation on books and things between. I'm the presenter, Huang Tianchun, and this presentation will mainly talk about the data analysis from a dataset related to books. Now let's first take a look at the dataset. It is provided at the year 2020 from the website Goodreads. It has around 1,100 books inside it, and it has 12 columns. Some of the interesting features are like the average rating, the language code, which is the language the book is written in, and the number of pages of that book. The first question we want to ask regarding this dataset is, what are the classic books? And the way we approach this question is by finding the most occurring books in this dataset. For example, the Iliad appears around 9 times in the dataset. Now here comes the next natural question. Why a book that occurs multiple times in the dataset can indicate that it is a classical book? That is because from the dataset before, there are some parts that are hidden from this example, like the published date, the publisher, etc. If a book, let's say the Iliad, is republished multiple times in different years, then in this dataset, it will have multiple rows corresponding to like Iliad and maybe published year 2000, 2001, 2002, etc. Therefore, a book that is republished multiple times indicates that it is welcomed by the reader and it is tested by the time, by the weathering of time. Therefore, the book that has the most occurring time proves itself a classic book. So we can see some familiar names like the Iliad, the Brothers, Karamazov, the Odyssey, etc. Now, the next question we want to ask is, how many books are written in each language? This is regarding the language code information we have before, right? And from this bar plot, we can see the book written in English has a very large number compared to other languages, like maybe the Spanish. And one thing to notice here is that all these EN, like ENCA, ENGB, ENUS, are essentially English. Therefore, to make this cleaner, I recategorize and combine all of them into one single language code called English. And from this bar plot, we can see, okay, there's a huge difference between the numbers, but I want to investigate the percentage of books written in English. And in that way, we need to leverage the pie chart here. As we can see, we see the English book consists of 95%. That is okay. However, the other part of the pie chart is a bit messy because the other language code has a very small number of books written in them. And therefore, the percentage is just so small to visualize here. Therefore, I did another recategorization and categorize all the other language codes into one single category called others. So we can have a very clear comparison between the number of books written in English and the number of books or the percentage of books written in others. And this is an alarming information or signal to us that some languages or many other languages may be disappearing because 95% of books are written in English. At the meantime, only 5% of books are written in other languages. That means most people in the world now are written in English form, and that leads to most people will read in English. And how about the other languages? How do we care about them? Where are they? So we need to be careful of this alarming information in the years to come to protect the multiple languages we have in the world. Our next question to ask is, what is the relationship between the number of pages and the average rating of a book? And from here, we can see the x-axis is the average rating of a book, and the y-axis is the number of pages. And one hypothesis or common knowledge usually shared by us is that people tend to give lower rating to the books that have longer number of pages, because usually, maybe even including myself, sometimes the people would be scared kind of the thick books, the book that has a large number of pages, and therefore people tend to give those books a lower rate. And this is a hypothesis, and we want to test that to see whether it will show itself during our data analysis of this book's data. And by looking at this joint plot, one thing we can notice is this. In the left part of this data set, there are actually very few data points allocated in this area. And this may skew our distribution or make our data set a bit hard to visualize. So one thing to do is to truncate the plot. I just discard those part that has X value that is above 3, which means I just throw away the average rating that is below 3. I guess one reason why is that people usually won't give very low rating, like rating 1, rating 2. Therefore, there are very few data points inside that area. Anyway, after the truncation, we can further our investigation into this relationship. And usually, if we want to check the relationship, we can look at the distribution of between the number of pages and average rating. By doing that, we can rotate this joint plot a bit, and we treat the x-axis as the number of pages from 0 to 1000, and the y-axis starting from 3. In this place is the average rating of 3, and the highest is the average rating of 5. And we can see that it seems that the books with the highest average rating usually lie between this range. This line corresponds to the 400 pages, and this line corresponds to the 200 pages. And this somehow testifies our former hypothesis that people usually prefer books that has a low or a small number of pages compared to a book that has a very large number of pages, right? However, when I try to do the statistical inference by calculating the Pearson correlation coefficient between the average rating and the number of pages, it seems that the number calculated is not very strong, or it shows that it is not statistically significant for the correlation between the variable average rating and number of pages. And this contradicts to our visualization here. We can see that, book with a number of page between 200 and 400 tends to have higher average rating. So what is the reason? Therefore, I further did my investigation by looking at subsample of the whole population. Here I list the top 10 authors, like J.K. Rowling. She has 17 books that has average rating that is beyond beyond rating 4. Therefore, I subsample the books and check what is going on here. And from this hierarchical data representation, we can see somehow in this, let's say the first dimension is the author, the second dimension is the length of the book. If a book that is below 200 pages, it is a short book. If a book that is between 200 and 600 pages, it is a medium book. And therefore, beyond 600 pages, it is a long book. And in the example of J.K. Rowling, we can see that actually long books have higher average rating than the medium books. And this is a contradiction to the trend or to the observation we have of the overall population. And this may somehow explains why there is a contradiction between the visualization and the statistical inference, because this may be true in the overall population, but this hypothesis does not hold when we go into certain subsample of the whole book population, like the J.K. Rowling books. Okay, so this is my questions and my investigations regarding this data set. Thank you for your attention and time to listen to this. Goodbye.